Okay, let's see some more chemical properties of aldehydes and ketones. Okay, so we'll see today the reduction. Can someone say what is reduction? Reduction, it's a chemical process where electrons are gained. Okay, so remember what is reduction? It's a chemical process where electrons are gained. So when the electrons are gained, what happened? It will decrease the oxygen state of a molecule. Okay, so electrons are gained. That means the molecule, we say the molecule is reduced and its oxidation state is decreased. Remember this. Okay, so what is reduction? Reduction is a chemical reaction or it's a chemical process where electrons are gained, resulting in decrease in the oxygen state and the molecule is reduced. Okay, so if we see the aldehydes and ketones, they have this carbonyl group, C double bond O. You see either the aldehyde or a ketone, it's having C double bond O. Now this aldehyde or ketone, you will do the reduction so that it will convert into the alcohol or it will convert into the alkane or hydrocarbons. Either it will convert into alcohol or it will convert into hydrocarbons. Is that clear? So whatever the aldehyde and ketone is there, it will undergo reduction process, and whatever this carbonyl group is there, it converts into the alcohols or hydrocarbons. Okay, so see here, in this reduction, we'll be seeing the aldehyde convert into alcohols or aldehydes converts into hydrogens. Okay, and if you see the difference between the aldehydes in ketones, aldehydes reduce more readily than the ketones. Remember that. Okay, so aldehydes, can someone tell me why could this happen? Aldehydes reduce more readily than ketone. Why?
Because ketone has two R groups attached to steric regions.
Yes, yes. Okay, because aldehydes have a less steric hindrance. If you see the ketone, it is having two big molecules. On either side, there are alkyl groups are present. These two are bulky groups. So they produce the steric hindrance. Whereas if you see the aldehyde, it's only having one bulk group, the other one is simple small hydrogen. So there will be less steric hindrance. So aldehydes, they can easily be attacked. So they can easily reduce than the ketones. Okay, so less steric hindrance due to single hydrogen atom present in the aldehydes. Whereas in the ketones, there are two alkyl groups were present. Okay. So let's see the reduction to alcohols. Okay. So aldehydes in the presence of NaBH4 BH4 or LiAlH4 or catalytic hydrogenation, it will convert into the primary alcohols. The same way ketones, it will convert into the secondary alcohols. So how does this will happen? You take the carbonyl group of both the aldehydes and aldehydes and ketones. Okay. So we know that oxygen is more electronegative. Yes or no? Is oxygen is more electronegative. And carbon is electropositive. So that creates the partial negative charge on the oxygen and partial positive charge on the carbon. So because of the oxygen being more electronegative, it creates partial negative charge on the oxygen and partial positive charge on the carbon. Okay, and this makes the polarity, and that polarity will act like, will make the carbon act like an electrophile. Okay, so because of this polarity on the carbon, which is partially positive charge, so this carbon, it will now act like a electrophile. What do you mean by electrophile? What is meaning of electrophile? Electron donate or electron seek?
Electron accepting.
Yeah, they are electron accepting or electron seeking group. Understood? So here the oxygen is more electronegative in nature. Carbon is more positive charge. So it will create partially positive over the carbon and oxygen will become partially negative. So that makes the carbon electrophile. So it acts like an electron seeking. Yes or no? If we have more positive charge, then what we do? We expect the negative charge. We expect the electrons to balance the charge. The same way here, carbon is slightly positive. So it is seeking for the electrons. So electrophile. So because of this property, the reduction in the carbonyl groups will happen. Understood? So as the carbon is seeking for the electrons, if you give the electrons, that is called the reduction. Okay, so both these aldehydes and ketones, they will be reduced to form the primary alcohols and the secondary alcohols. Okay, and mainly it happens through two main methods. One is using the metal hydride. So remember, there is a two main methods. So one is using metal hydrates, and the two is catalytic hydrogenation. So using metal hydrates. Okay. So here we will be using the sodium borohydride, NaBH4, which is a metal hydride. Or you will be using the lithium aluminum hydride. You can be use either the sodium borohydride or you will be using the lithium aluminum hydride. Remember the names are very important. This is sodium borohydride or you will be using lithium aluminum hydride. So that's the first step. First method is you will be using either the sodium borohydride or lithium aluminum hydride so that primary alcohols will be created. Or you can use the second method, that is catalytic hydrogenation, where you will be using the hydrogen gas which with a metal catalyst. Okay, remember. The second one is we will be using the hydrogen gas with metal catalyst. Is that clear? So why does the aldehydes and ketones, they will undergo reduction? Because oxygen is partially negative charge, carbon is partially positive charge. Because of this, the carbon acts like an electrophile, which is electron seeking, which is looking for the electrons to get. And where does these electrons? If you donate the electrons with the help of the sodium borohydride or catalytic hydrogenation, this aldehyde will convert into primary alcohol. Ketone will convert into secondary alcohols. Okay, and remember aldehydes, they reduce more readily compared to the ketones. Okay, because of less steric hindrance seen in the aldehydes. Whereas here two alkyl groups are present, so bulky groups are present, it's very hard for the ketones to undergo reduction compared to aldehydes. Clear? First, suppose let's take an example. Is this clear? Any doubts?
No, sir. No, sir.
Okay, perfect. Next one. So Clemmensen reduction. Remember the neighbor reactions are very, very important. So the next one is Clemmensen reaction. So what is this Clemmensen reaction? Here you will be converting the aldehydes or ketones into the alkanes. In the previous condition, we converted into primary, secondary alcohols. Whereas here, aldehydes and ketones, they will be converted into the alkanes, hydrocarbons. Okay, that's what we saw here, right? So first, reduction to alcohols or reduction to hydrocarbons. So this method where you will be converting into the alcohols, in this method, you will be converting into hydrocarbons. So remember, Clemmensen reaction, Clemmensen reduction, where the aldehydes and ketones, they will be converted into the alkanes. But here the most important catalyst is zinc amalgam. Okay, so just remember the zinc amalgam, which is nothing but the ZnHC in presence of concentrated HCl. Okay, so see here. So it could be an aldehyde or it could be ketone. Ketone if it is both are RR. Aldehyde if it is R and H. Okay, this in presence of zinc amalgam, that is ZnSC, concentrated HCl, it will be converted into CH2, which is a alkane. Okay, and see here, if you see here, what is the hybridization on this carbon? What is the hybridization on this carbon? Remember, if any group is having single bond, the hybridization is sp3. If it is having double bond, hybridization is sp2. If it is having triple bond, hybridization is sp3. Remember this. Okay. So now tell me, what will be the hybridization on this carbon?
sp2.
It is sp2. And what is the hybridization on this carbon? All are single bonds.
sp3.
So it is a sp3. Okay. So remember this. So let's see an example for the Clemmensen reaction. So CH3CHO. So what is this? Is this a ketone or aldehyde?
Aldehyde.
Aldehyde.
Yeah. So in the presence of zinc amalgam, concentrated HCl, and you need to eat this process. So it will be giving the alkanes plus water. Understood? So what's happening here? What is this group called? What is this group called? Come on, guys, tell me, what is that group? What is the reactant there?
So which
The reactant. What is the reactant?
aldehyde group?
Aldehyde.
It's a aldehyde. So see here, what is the name actually? This is the aldehyde. Okay, fine. But what is the name? How many carbons are there?
One,
Nitya, look properly. How many carbons are there?
two,
Two carbons are there. So if it is two carbons, what we call?
ethanol.
Yes, perfect. So it is a ethanol. What is the other name for ethanol? Acetaldehyde. Remember. Okay. So you can also call this as the isner acetaldehyde. So this ethanol acetaldehyde, it will be reduced to ethane. Remember this. In the presence of zinc amalgam. Okay. So this is the zinc amalgam. And you need to have the concentrated HCl and you need to eat this. Okay. So under the eat condition. So what's happening here? What is the Clemmensen reaction? The ethanol, which is acetaldehyde, is reduced to ethane using the zinc amalgam. Okay. And concentrated HCl under eating condition. Understood? So what is the purpose of the zinc amalgam is it acts like a reducing agent. Remember this. So this acts like a reducing agent. Can someone tell me what is the meaning of reducing agent? See, this compound is reducing. Then what is the purpose of this compound? This compound, it is reducing. That means it is seeking for the electrons. So someone has to supply those electrons. Here the zinc amalgam is supplying those electrons. Understood? So
Yes,
here
sir.
the ZnHC is a zinc amalgam. So where it supplies the electrons to this ethanol. So this ethanol will take those electrons and it will reduce to ethane. Is that clear? Banu, you got it?
Yes, sir.
Okay. What about you, Sharon?
Yes, sir.
Next one. So CS3, C double bond O, CS3. So in the presence of same zinc amalgam and concentrated HCl. So it will be giving into. So can someone tell me what is the compound it will be giving? Here ethanol has given the ethane. So what is this? What is this? Tell me what is this? 3 carbons. Sharon, you tell me what is this? Is this aldehyde or is that a ketone? Sharon, open your mouth.
Ketone, sir.
Huh?
Ketone, sir. Ketone.
Yeah, it's a ketone. And there are 3 carbons are there. So what do you call? 3 carbons, we call it as prop. And what is the suffix for the ketone? Non. So what do you call? Huh? Srika, you tell me, what is this?
Propanol.
Propanone. So this is a propanone. What's the other name for propanone? It's also called as acetone, remember. Okay. So CS3, CO, CS3. It's a propanone or acetone. That will be reduced to Mandara, it will reduce to what?
Propane, sir.
Yes. So it will be reduced to propane. So is that clear? So what happened here? The propanol, which is a ketone, it is reduced to propane using the same conditions. Whatever the zinc amalgam is there, here also we are using the zinc amalgam and concentrated HCl. And you need to eat this reaction. Okay. So this reaction, we call it as Clemmensen reaction. Okay. So what is Clemmensen reaction? This is used to prepare the alkenes from the aldehydes and ketones, where you will be using the reducing agent, the zinc amalgam, okay, and concentrated HCl. So whatever the C double bond O, which is a sp2 hybridization, now it will convert into the sp3 hybridization, where all the double bonds will be disappeared and it will form the hydrocarbons. So that is Clemmensen reaction. Any doubts so far?
No, sir.
Perfect.
No,
So
sir.
next one, Wolff-Kishner reaction. Okay, so what's happening here? Here also we'll be taking the carbonyl compound, either the aldehyde and ketone, and we will be converting into the alkanes. Okay, but whatever the reducing agent we are using here, the zinc amalgam, we are using here some different reducing agent. Actually, we will be using the hydrazine. Okay, so what is hydrazine? NH2, NH2. So this is called as the hydrazine. Remember, and here you used the strong HCl, concentrated HCl, which is a strong acid. Here you will be using the strong base. Okay. So you will be taking the base here, which is a potassium hydroxide. And here you supply the heat the same way here you need to supply the high boiling solvent, which is ethylene glycol. We'll see what is that. Okay. So let me write a reaction. So let's take a carbonyl compound, either it can be the aldehyde or ketone. So this in the presence of NH2, NH2. So what do we call the NH2, NH2 as? Hydrazine, remember. Okay. So, and strong base, potassium hydroxide. And you also need to supply the boiling solvent, which is ethylene glycol. So that it will produce the hydrocarbons. So from this, you can tell that the hydrocarbons from the aldehydes and ketones can be prepared through 2 ways. One is Clemmensen reduction reaction, where you will be using the zinc amalgam, and you can be also prepared by the Wolff-Kishner reduction. Understood? But here we will be using the hydrazine. So this is called hydrazine and a strong base, potassium hydroxide. It will be giving the hydrocarbon, which is sp3. Here double bond is present, so it's a sp2. So let me take an example. So CH3 CHO in the presence of NH2 potassium hydroxide, and you need to eat this process so that it will be giving hydrocarbon. So what is this compound called? CH3CHO? Srikar, what is this called? Aldehyde or ketone?
Aldehyde.
So what do we call?
Ethyl.
Ethanol.
Ethanol.
Ethanol. Or you can also call this as acetaldehyde.
Acetaldehyde.
Okay. So that will be giving the ethane. Okay, now solve this.
Sir,
Yeah, Nitya.
sir, in the previous reaction, ethylene glycol is not used while reducing aldehydes.
Ethylene glycol as well. Okay.
Okay, sir. And then in reducing ketones, heating is not required, or is it required?
Here. It is also required. It is also required.
Okay.
Okay. Yeah. I just took only one example. Okay.
Okay, sir.
Solve this question.
So could you go one slide back just a minute? Sir, what is that NH2 called?
Which one? NH2
Ah,
hydrazine.
Yeah. Done, sir.
Okay. So see here. Tell me what could be the answer.
Sir, option D.
Yes, sir.
Option D.
B.
Option B.
No, sir, D. D for Delhi.
Okay. So Nitya says option is D. What about the others? Shrikar, what's your option?
Sir, I guess D only.
Banu, what about the others?
So D.
I think D.
Sharan, are you there?
Yes, sir.
Why, Sharan? You are so silent in the class.
No, sir, I said.
Okay. Mandara, you tell me what it will come if we use the option A. If we use the ketones or aldehydes and you react with the NaBH4 and CH3OH, what does it will give?
Primary and secondary alcohols, sir.
Yes. It will give primary or secondary alcohols. Actually, it will give secondary alcohols since it's a ketone. Understood?
Yes, sir.
Yeah. So both zinc amalgam and S2 and NS2 will give the alkanes, right? So the option is D. Whereas this option, it will give alcohols. Okay, so the carbonyl compound will convert into the alcohols. So tell me, which reaction is this? Clemmensen reduction of a ketone is carried out in the presence of the following. So what's the reducing agent we use for the Clemmensen reaction?
B.
Option B.
What is that name?
Zinc amalgam.
Yeah, it's a zinc amalgam. For reducing to alcohols, what is the catalyst we use?
LiAlH4.
Lithium aluminum hydride or sodium borohydride. Okay, that's a NaBH4. NaBH4, or we can also use LiAlH4, which is a lithium aluminum hydride. Okay. For Clemmensen reaction, we will be using the zinc amalgam and concentrated HCl. Okay. And for Wolff-Kishner reaction, what is the catalyst we use?
Hydrogen.
Hydrazine, which is NH2 in the presence of strong base, which is KOH. Okay. So remember this. So here the answer is option B. So next one, what is the option? So here, what is this? What is this called?
Ketone.
It's a acetone. So this acetone, when you treat with, what is this? Ethylene glycol. This is a previous class question. In the presence of HCl, what does it will happen? Do you remember? The OH and OH, here double bond O.
Sir, option B.
Option B.
B.
Okay, so that will be giving this thing. So when carbonyl compound, it's treated with this ethylene glycol, it will be giving the cyclic acetal. Remember, or ketol. You call this as cyclic. I told you the mechanism, if you remember. Cyclic acetal, or you can also call this as the ketol. Good. So tell me this, hydroxyketones are not directly used in Grignard reagent. Grignard reagent reacts with a hydroxyl group. Hydroxyketone, what does that mean? You take a ketone, let's say C double bond O, it contains the C, which is having the hydroxyl group. So you see here, this is R C double bond O R, but this R is containing the OH group. So such compounds, we call it as the hydroxyketones. Okay, actually this compound is called alpha hydroxyketone. Okay, so what happens if it reacts with the Grignard reagent? See here, if you take the hydroxyketone, that means, let's take an example. Okay, so this is called as alpha hydroxyketone. So when you take compounds like this and you treat directly with the Grignard reagent, what happens is, so here whatever the OH is there, okay, we call this OH as a acidic proton, because this OH will turn out to be O minus H plus. It will donate the protons. So that's why it is called as the acidic protons. Okay, so what happens here, this hydroxy group will be attacked by the Grignard reagent. Okay, so Grignard reagent will rapidly react with these hydroxy groups. Okay, whatever the hydroxyl groups are there, write down this. So whatever the hydroxyl group is there, hydroxyl group in hydroxyketone which has the acidic proton, so will react rapidly with Grignard reagent. Understood? And these Grignard reagents are strong bases. And here this hydroxy proton will act like acid. So they react, both the base and the strong acid will react fast very quickly. Okay, so that's why we should not directly use the Grignard reagent with the hydroxy ketones. So option A is correct. So what happens? Grignard reagent reacts with hydroxyl group. So both option A is correct, and the reason is giving the correct explanation to assertion. Is that clear?
Yes, sir. Yes, sir.
Okay. So next one, the reaction of a carbonyl compound with one of the following involves nucleophilic addition followed by the elimination of water. So where do we see that? Do you remember?
Sir,
Yes. So where do we use the hydrazine? So where do we see this one?
Wolff-Kishner reaction. Ready.
Yeah. Okay. So it's a Wolff-Kishner reaction. So remember this. Okay. Let me show you the reaction. For suppose you take a carbonyl compound. Let's take a carbonyl compound. So what is this group called? Is that a ketone or aldehyde?
Ketone.
It's a ketone. Okay. So this ketone, when you react with a hydrazine, do you remember the previous class, how the nitrogen will attach in the presence of double bond O?
Yes, sir.
So how does this reaction will happen?
Yes, sir. N will get attached to it.
And will attach to?
C double bond.
Yeah. And will attach to C double bond.
And that O and H2 will become H2 in the product.
Yes. It will form water. Okay. So what's happening here? There will be addition elimination reaction. If you remember, just go with the previous class. I told you that there is a addition elimination reaction. Okay. So I'm not going in detail explanation of how this mechanism. I told you in the previous class. Just go with that. So see here. So what's the answer now? Hydrazine in presence of feebly acidic solution. That will give the nucleophilic addition reaction and the elimination of the water. So nucleophilic addition, as the nitrogen is added and the water is removed. Okay. So elimination reaction. So next one. So tell me what will be the product? So acetone is that aldehyde or ketone?
Ketone.
Ketone.
So that ketone, when it reacted with the ethanol and alcohol, what it will form? Okay, just let me draw it. So it's a acetone, right? So it is CH3, C double bond O, CS3. When it reacts with the ethanol, so take it C2H5OH. Actually, you will be taking the 2 moles of this ethanol. Okay, so what happens? Where does the bond breakage will happen? In the presence of hydrochloric acid.
The double bond O will break.
Yeah, the double bond O will break. And here, hydrogens will break. You got it? Remember? Okay, so in place of double bond O, now each oxygen will attach. If you remember, this also we discussed in the last class. So that will result in formation of a compound which is CH3 twice C in place of double bond O. Now single bond will be attached to each group. So it will be attaching to C2H5O, or you can say OC2H5 and OC2H5. So what's the option here?
Option
The
D.
D. Okay, so understood. If you don't remember, just go with the previous class once again. I think I kept the video in the YouTube. So next one. So see here. So predict the major product from the following reaction. What is that? CrO3H2SO4, which acts like a oxidizing agent, and it will convert into the secondary alcohol. So here you will be getting the secondary alcohol. Now these secondary alcohols, okay, will undergo nucleophilic addition takes place, and cyanohydrin is obtained as the product. Understood? First, suppose you take the alcohol. Okay. So this alcohol in the presence of CrO3H2SO4. What it is given? It will convert into the ketones. Okay. So how does this will convert? So in place of OH, it will convert into the double bond O. This is a ketone. Okay. And in the presence of cyanohydrin, which is NaCl and HCl, cyanohydrin will be obtained. Okay. So this will further react with NaCl and HCl. It will give the cyanohydrin. What is cyanohydrin? OH and Cn will be attached to the same carbon. Okay. So this is called cyanohydrin. Finally, the last one. So tell me, what is this? Which of the following carbonyl compound reacts with HCN to give the lowest yield of the cyanohydrin? What is the answer? If you remember this thing, I told you one important thing when we discussed about this. Okay. So more the steric entrance, lesser the yield will be. Remember, I told you that in the last previous class, we discussed about this. So the more the yield, the more the steric entrance. So what is steric entrance?
Bulkiness of the.
Yeah. The main carbon is surrounded with the bulky groups, right? So when it is surrounded with the bulky groups, approaching the main carbon is very difficult. So the more the steric entrance, lesser the yield. So what is the yield here? The cyanohydrin. Okay. So tell me which one will be the bulkier group here? The one which is having the tertiary carbon, right? So which one is having tertiary?
Option D.
Yes. So option D. Next one, when aniline reacts with a oil of bitter almond, condensation takes place and benzyl derivative is formed. This is known as. So you take the aniline. What is aniline? Benzene group with
NH2.
NH2. So this aniline, when it reacts with a bitter almond, that is C6H5CH4, which is nothing but the benzene group with the aldehyde. So what happens now? It will form, in place of nitrogen, what happens now? How does the connection will happen? The hydrogens will be removed. In place of C double bond O, the N will attach, if you remember. So this will be forming the compound like this. And water molecule will be removed. Understood? This also we discussed. So what is this reagent called? If you remember, Skipp's reagent. Please go with the class. Once the class is completed, just revise it. Otherwise, you will not remember anything. It's called as the Skipp's base. So that's it. We'll call off the day. Any doubts? Come on, guys, answer. Any doubts?
No, sir.
No, sir.
Okay, I'll just share this PPT. Please go and also revise the previous classes.